We're going to do E1. That's an elimination reaction. Now, to name the players, we need a nucleophile, which is this one, but we're going to call it in E1, we're going to call it a base, and that is this molecule right here. We need a substrate, and that is this molecule here. And then we need a leaving group. So we said that halogens, they make really good leaving groups. So these are the name of the players. We got our base, substrate, and leaving group. So we have all of this here. So we know that this we wanted to undergo E1. So the mechanism for that, this is the expected product. We get an alkene. So the way this happens is, first thing, you got to remember that E1 is carbocation intermediate. It's a carbocation intermediate, so we expect the formation of a carbocation. It happens in step 1. What happens is the leaving group takes the electrons of the bond right here. And then you have a carbocation on this carbon, and you can even write plus Br minus, because it took the 2 electrons of the bond, and the base is just waiting there. Then in step 2, what happens is the base come in and it takes the proton from the beta carbon. So the way this works is alpha will be the one having the leaving group, and we have 2 beta carbons, and the protons in those are slightly acidic. So since this one is slightly acidic, this is a CH2, so I just wrote the H here, and I wrote the H on the bottom. So the base is going to pick it up, and then this bond is going to break, and it's going to make a double bond right here to stabilize this carbocation, and the product will be the formation of a double bond. Now you must be wondering, okay, well, if we have 2 beta carbons, then how come it doesn't take it from this one? It does take it from that one. And what we're going to see is this happening. You have CH3, CH double bond. No, I'm sorry, that's CH2. You have your carbocation right here. And then you have your CH2 here. And I'm going to draw the H here. Now when the base, which we said is this one right here, when the base comes and picks this one up, and this one goes up here to stabilize the carbocation, the expected product is CH2. So now, if we see, we get 2 products. We get this one right here, and we get this one right here. And if we notice the stability of alkenes, this one is a more substituted alkene. It's a more substituted double bond. So this one will be more stable. So this one will be your major product. And this one will be your minor product. I get it easier when we draw them like this. And then if we're going to make this one, we draw that. if we're going to make this one, we draw it like this. So you can see that the two carbons in the double bond and this one has two substituents, 1, 2, and this one has only one substituent. So this one is your more stable product, which is this one right here. So that's why I went with that one. But you will get some of that, and that will be your minor product. Okay, an example 41. We have this reaction. So just to name the players again, we have the base, which will be an AOH. That's a pretty strong base. We have the substrate that I will say, okay, 1, 2 CH3s. So CH3, 2. Then I have a CH, another CH, and then a CH3. And then my leaving group, an excellent leaving group I, which is halogen. Okay, so we have this, we have our base, and that's the expected product. So we know E1, it's carbocation intermediate. So we know that the first step is the carbocation formation, which would be the rate determining step. So what's going to happen is, I'm just going to copy this right now. CH3, CH, we have the I here, and then CH3. The base is not going to play any role in the first step. So the I is going to take the electrons of the bond and is going to leave. That's what leaving groups do. So what we're going to get is CH3, H, then we have CH, we have a carbocation, an empty orbital right there, and then we have a CH3. Again, this carbon has an empty orbital, or it has a positive charge because it only has 3 things attached to it. It has 1 bond here, 2 bonds here, and 1 bond with the hydrogen. And you know carbon has to be attached to 4 things. So since this one is only attached to 3 things, it's missing 1. That's a plus charge. So I'm going to copy that. If you want to write the base here, that's fine, NaOH. So I'm going to copy whatever's on that side. I will say CH3, CH3, and then CH. We have our carbocation right here, and CH3. So what I have right here is a potential for a more stable carbocation. A tertiary is more stable than a secondary. So I am going to draw this hydrogen right here. And what will happen is a 1,2 hydride shift. This hydride is going to come here. And the result, we still got our base, just waiting. So the result will be our carbocation right here, empty orbital, CH2, because of the hydride, it already has a one hydrogen, and then the hydride is going to come, so we get a CH2, and then CH3. Okay, so now we have a tertiary carbocation, which is more stable than secondary. We still have the base right here, NaOH. And then I'm going to copy that right here. CH2, and CH3. Now, what I'm going to do is I'm going to draw one of the hydrogens right there. So, now the elimination reaction, this one's formal charge plus. Now the NaOH, the oxygen being electronegative, is going to pull this beta hydrogen. We have to remember that this will be alpha, this one will be beta. This beta hydrogen is going to be pulled by the OH, and this bond right here is going to come and it's going to stabilize the double bond right there. Because this carbon now is going to have 4 bonds again. If this bond comes here, it's going to have 1, 2, 3, and the double bond is going to be 4. So that will be more stable. So what we get is a CH3 here, we get our C here, CH3 up here, then we get the double bond, CH and CH3. Now, again, another valid question would be, why doesn't it take one of these hydrogens? So if we draw the product, this one right here will look something like this. You got your double bond right here with this carbon and one coming out. And then if you take it from this one, then the product that you should expect is 1, 2, 3, 4, 1, 2, 3, 4. You have one here, and you have a double bond here. So, if you look at stability of alkenes, it tells you that the more substituted alkene will be the more stable one. So what you look at is the carbons that are in the double bond, and you say, okay, this one in here doesn't have any substituents, and this it has 1, 2, so there's 2 substituents in this one, and in this one there is 1, 2, 3, and this one you have 3. So the more stable one is going to be the one with more substitutions right there. So this one, which is this. So you expect this to be your major product.